Hello everybody, Root Beer here once again. We're up to question number 6 on the year 2000 Pascal paper. Okay, so what does question 6 say? Hopefully you've downloaded a copy of the contest by clicking the link in the description, and you've had a chance to look at question 6 for yourself. So question 6 says, if 2/3, 23 30ths, 9 tenths, 11 15ths, and 4 fifths are written from smallest to largest, then the middle fraction will be... Okay. So it's very, very, very difficult to compare fractions. It's not impossible, but very difficult to compare fractions when they don't have a common denominator. So the first thing I would say is, let's get a common denominator. Okay, and there's a couple ways to do it. We could guess and check, or, I mean, you could probably just say to yourself, well, 30 on the bottom, I mean, 5 is a factor of 30, 15 is a factor of 10 and 3, those are factors of 30. So we could get a factor of 30 on all the bottoms. But suppose it were a harder question. Okay? How can we get a common denominator for a bunch of fractions? Okay? So this is, oops, we're stuck on blue. That happens every once in a while. So when I'm faced with two numbers, I usually just multiply their denominators to get a common denominator. But if I have a group of numbers, I mean, I don't want to be multiplying 3 by 30 by 10 by 15 by 5. That's going to be a huge number. So when I have a group of common fractions, I use this method. And you might be saying, it's obviously 30, why are we doing this? In case you ever encounter a harder question, I mean, you can do these questions one at a time and solve them perfectly, but you won't ever learn techniques if you don't stop and try and figure out a more general problem. So the first thing we're going to do is factor each denominator. So we have 3, and well, that's just 3. Some might call it 3 to the power 1. We're breaking everything down into its prime factors. 30. Well, it can take a little while, but we can figure out that 30 is actually 2 to the power 1 times 3 to the 1 times 5 to the 1. Okay? How about 10? Well, that's 2 to the 1 times 5 to the power of 1. 15, that's 3 to the power 1 times 5 to the power 1. And finally, 5 is just 5 to the power of 1. Now, for each prime number, pick the largest exponent . And we're going to multiply all these prime powers together. Okay, so I see 2s, I see 3s, I see 5s, and the largest exponent for each of them is 2 to the power of 1. So my common denominator is going to be 2 to the power of 1 times 3 to the power of 1 times 5 to the power of 1. And hey, look at that, it's 30. Okay, so this doesn't seem to be a particularly interesting example, but suppose instead, and I'm going to erase this so that we don't get confused, but suppose instead we had 4, and we had 6, and we had 8, and we had 5, and we want to find the lowest common multiple, the common denominator. So suppose these are the denominators of some fractions. We have 2 to the power of 2, 2 to the 1, 3 to the 1, 8 is 2 to the power of 3, and 5 is 5 to the power of 1. Okay. Here, we have some 2s, we have some 3s, and we have some 5s. So we take the largest power of 2 we can find. That's 2 to the power of 3. And then 3 3 to the power of 1, 5 to the power of 1. Okay, and in this way, we get a number. I think we get 120. And there we didn't just have 2 to the 1s and 3 to the 1s and so forth. We had some 2 to the 2s and 2 to the 3s, things like that. And so you take each prime that you can find in turn. I mean, we don't care about 7 or 11 or anything like that. The largest prime power for each prime we can find. So that's to the 3, to the 1, to the 1, and we just multiply them all together. And that will be a suitable common denominator. In fact, it'll be the lowest common multiple of each of these denominators. So as I say, that's just another example to help show you how to use this technique. That's okay. If it hasn't sunk in, that's okay. It's question 6. We shouldn't be stressing too much about this. So common denominator of 30. Now let's take each of our fractions in turn and give them a common denominator of 30. So 2 over 3. Well, how can I make that 3 a 30? I multiply by 10. So I get 20 over 30. 3 over 30, well, that's just 23 over 30. Okay, I think the next one is 9 over 10. Yeah, 9 over 10, 11 over 15. And finally, 4 out of 5. So we want to get 30, so we multiply top and bottom by 3. So we get 27 over 30. Here we want to multiply top and bottom by 2 in order to make this denominator 30. So 2 times 11 on top, that's 22 over 30. And finally, what do we need to multiply 5 by to get 36? 4 times 6 is 24, 5 times 6 is 30, and that's how we multiply fractions. So what is the middle one here? Well, now that we have a common denominator, we can properly order them. 20 over 30 is less than 22 over 30, less than 23 over 30, 24 over 30, and 27 over 30. So our middle one, 23 over 30, and I think that was B. No, it was A. So we get an answer of A, 23 over 30. So that was a nice little question. We had to do common denominators, and then we had to compare. So first we had to know that it's much easier to compare fractions when they have a common denominator. Then we had to find it, and then we ultimately did have to compare them and find the middle fraction. Now there are other ways to do this, certainly, but I think this is probably the easiest way to do it. And if you didn't know it before, now you have sort of a general idea of how to find a common denominator for a group of fractions. So we're learning lots, and hopefully we'll be learning just as much and have just as much fun on the next question, question number 7.